let's say that we are dealing with a geometric series, and there are some things that we know about this geometric series. For example, we know that the first term of our geometric series is a. So that is our first term. We also know the common ratio of our geometric series, and we're going to call that r. So this is the common ratio. And we also know that it's a finite geometric series. So let me write this. It is finite. So it has a finite number of terms. And let's say that n is equal to the number of terms. And we're going to use a notation. We're going to use the notation S sub n to denote the sum of first n terms. And the goal of this whole video is using this information, coming up with a general formula for the sum of the first n terms, a formula for evaluating a geometric series. So let's write out S sub n, just get a feeling for what it would look like. So S sub n is going to be equal to, well, you have your first term here, which is an a. And then what's our second term going to be? Well, it's going to be, this is a geometric series, so it's going to be a times the common ratio. So it's going to be the first term times the common ratio. So the first term times r. Now what's the third term going to be? Well, it's going to be the second term times our common ratio again. So it's going to be AR times R, or AR squared. AR squared. And we could go all the way to our nth term. So we're going to go all the way to the nth term. And you might be tempted to say it's going to be A times R to the nth power, but we have to be careful here. Because notice, our first term is really AR to the 0th power. Our second term is AR to the first power. Our third term is AR to the second power. So whatever term we're on, the exponent is that term number minus 1. So if we're on the nth term, it's going to be AR to the n minus 1th power. So we want to come up with a nice, clean formula for evaluating this. And we're going to use a little trick to do it. To do it, we're going to think about what r times the sum is. And we're going to subtract that out. So we're going to take the r times that sum. R times the sum of the first nth terms. Actually, let's just multiply negative r times that sum, and then we can just add these two things, and you'll see that it cleans this thing up nicely. So what is this going to be equal to? This is going to be equal to, well, if we multiply a times negative r, we will get negative AR. And I'm just going to write it right underneath this one. So if you multiply this times negative r, I'm just going to multiply every one of these terms by negative r. That's equivalent to multiplying negative r times the sum. I'm distributing the negative r. So if I multiply it times this term, a times negative r, that's going to be negative AR. Then if I multiply AR times negative r, that's going to be negative AR squared. Negative AR squared. You might see where this is going. And just to be clear what's going on, that's that term times negative r. Times negative r. This is that term times negative r. And we would keep going all the way to the term before this times negative r. So if the term before this times negative r is going to be negative. So let me put subtraction signs. It's going to be negative a times r to the n minus 1th power. R to the n minus 1th power. That was the term right before this. That was a times r to the n minus 2 times negative r is going to give us this. So it's going to get us right over there. And then finally we take this last term and you multiply it by negative r. What do you get? You get negative a, and then times r to the n. R to the n. You multiply this times the negative, you get the negative a, and then r to the n minus 1 times r, or times r to the first, well, that's just going to be r to the n. And now what's interesting here is just we can add up the left side and we can add up the right-hand side. So let's do that. On the left-hand side, we get S sub n minus r times S sub n. And on the right-hand side, we have something very cool happening. Notice, this a, we still have that. The a sits there. But everything else, except for this last thing, is going to cancel out. So these two are going to cancel out. These two are going to cancel out. Let me do that a little neater. These two are going to cancel out. These two are going to be cancel out. And all we're going to have left with is a negative a r to the n. So it's going to be a minus a times r to the nth power. And now we can just solve for S sub n, and we have our formula, what we were looking for. So let's see, we can factor out an S sub n on the left-hand side. So you get an S sub n, the sum of our first n terms. You factor that out, so it's going to be times 1 minus r is going to be equal to, and on the right-hand side we can actually factor out an a. So it's going to be a times 1 minus r to the n. And so to solve for S sub n, the sum of our first n terms, we deserve a little bit of a drum roll here. S sub n is going to be equal to this divided by 1 minus r. So it's going to be a times 1 minus r to the n over 1 minus r. And we're done. We have figured out our formula for the sum, or for the sum of a finite geometric series. And so in the next few videos, or in future videos, we will apply this. And I encourage you, whenever you use this formula, it's very important, now that you know where it came from, that you really keep close track of how many terms you are actually summing up. Sometimes you might have a sigma notation. It might start its index at 0 and then goes up to a number, in which case you're going to have that number plus 1 term. So you have to be very careful. This is the number of terms. This is the first term here. We define it up here. N is the number of terms, the first n terms. R is our common ratio.